Hello there, this is Sandeep Arora here. Welcome to my channel. Today I want to talk to you about distillation fine-tuning. This is part of my AI mindset series. So as we move into 2026 and companies and teams start to move AI into their production workloads, what they realize is the AI cost start to shoot up, okay? And also, when you put AI behind your real-time use cases, latency could become a problem if you are using large language models for everything, okay? So, distillation fine-tuning is a technique where you're going to use a large language model to teach a small language model to mimic it for a specific task, okay? Let me repeat, you're gonna use a large language model, you know this is good, you know accuracy is acceptable to you for your use case. Now you're gonna use this large language model to teach a small language model to mimic at the same accuracy or better for your use case. So this technique is very important, okay? It's very important, number one, and it's easy to do because you don't need human labeling, okay? The data is generated by the large language model, all right? So it's an important technique, okay? It's easy to do as you begin your AI journey and as you mature from prompting to fine-tuning. And also it addresses a very critical thing, cost and latency. See, because there is not enough compute in the world, and many of these large language models are rate limiting, okay, and they might even increase cost. So you don't want to be in a situation where suddenly your costs are going up, or the costs are so much that you don't have enough budgets for other use cases. So let's take a closer look of how this works. I'm gonna walk you through a use case which OpenAI has on their website. Let's take a closer look. Okay, so this is what distillation looks like. You have a large model over here, maybe 70 billion parameters or 300 billion parameters. This is the teacher model, okay? And because of its size, the cost is high, latency could be high as well, but accuracy is also high. So now you're gonna use this as a teacher model. It will generate data, synthetic data for your use case, for your specific task. And then using this data, you're gonna fine tune the small language model using this data. Okay, so the small language model becomes the student and this is the teacher. Okay, now let's take a look at this cookbook. All right, so from OpenAI, here it uses GPT-4o as the teacher model and it uses GPT-4o mini as a student model. So let's see what cost savings are possible. Okay, so the task over here is to classify the grape variety given wine reviews. Okay, so the review data is in this format. Okay, description, province, region, etc. And then this has to be classified. And remember, this is a pretty complex case because there are over 10,000 grape varieties in the world. So as I said, right, we are going to use GPT-4o to create this data. Okay, so we have these reviews and a prompt is created and we are going to create input output pairs just like I told you over here, and the input is based on this wine review. The wine is produced in this winery, in this region, in this country. This is the description. Now tell me what grape variety it corresponds to. Okay, and the large model will output the grape variety. So you're gonna, this is your synthetic data, input output, okay, pairs, just like this. And then you basically teach the the small model, which in our case is GPT-4o mini. Okay, so now what happens after this distillation fine tuning is, see, before distillation the accuracy of GPT-4o was around 79-80%, and the accuracy of 4o mini was 65%. After distillation, the accuracy of GPT-4o mini went up to 79%, right? Almost equivalent to the accuracy of a large language model. So just to come back here, after distillation, the small model accuracy was equal to the accuracy of the large language model for this specific task, right? And the outcome of that is the cost fell around 94% per request. Okay, so that's a dramatic incremental cost. So that's really a dramatic lower cost as compared to using a large language model, and the latency is going to be good as well also, right? So this is a pretty good use case, and similar use cases, like you're classifying the grape. There are many use cases like that in industrial engineering, in finance, in health, like in law, based on the evidence, what code of law case it is, things like that. So hope you understood. I'm gonna see you later again. Take care.